set, go. A hockey team plays in an arena with a seating capacity of 15,000 spectators. Would you like to have 15,000 spectators at your sport? That'd be pretty cool, huh? That'd be awesome. With the ticket price set at $14, the average attendance at recent games has been 9,500. Okay, so they got some room yet. A market survey indicates that for each dollar the ticket price is lowered, what do you think is going to happen if we lower the ticket price? What's going to go up? The attendance, right? We expect the attendance to go up. So the average attendance increases by 1,000. Find the price that maximizes revenue from ticket sales. So we want to make the most amount of money, right? Does that sound like a good idea? Does that sound like something people would like to do in their businesses? Yeah, most business owners can't figure those types of things out. They try to hire mathematicians to do that for them, okay? So, and then you make like a bunch of money. So, let's figure it out. So, we need to model the problem. So, let's draw a ticket. Because we're selling tickets, right? Should we put like $14 on it? The T for ticket. Does that help us model the problem? No, not at all. That's absolutely just dumb, okay? Gotcha. Right, exactly. Writing a ticket doesn't help us at all. So, the fact is that, good way. What am I trying to do? What's the goal? I want to maximize revenue. So, I want to figure out how I actually get revenue. How do I get revenue? How do I make money? I sell tickets. For how much right now? $14 times, or currently how many spectators do I have? 9,500. Would that tell you my current revenue? Good. Like if you can't even figure out your current revenue, you're going to have no chance of like maximizing it, right? See what I'm saying? Like when you don't know how to do a problem, just do the problem. Like try to figure out some revenue. Well, now let's see what happens. Revenue is equal to, what would we like to do to that 14? We would like to lower it by like $1, right? So let's say we subtract 1 from 14. Then I'm going to have 9,500 plus what? Plus 1,000. Yes, no? And then suppose I had 14, suppose we lowered it $2. There will be 9,500 plus 2,000. We'll do even one more just to make our point. 14 minus 3 would be 9,500 plus 3,000. Look at that. I mean, to me, that looks like some useful information. So I didn't draw a picture, but I modeled the problem in a helpful way. You see, folks, that's the difference. That you want to get to a point where you can kind of think through some of that, start kind of come up with a strategy. That's one excellent way. So we'll see who can see it now. Revenue is equal to, look at what stays the same and look at what changes. Somebody give me an expression, but give me a variable. Good, I like 14 minus x times. Excellent. Look at this number. If this is x, this number is 1,000 times x. Cool. Now you're feeling smart, aren't you? Let's multiply it out. Revenue is equal to, I'm going to multiply my x as negative x times 1,000x. Cool. And then I'll do the inside and the outside. The outside is 14,000x. And then this inside is negative, yes. Because I have negative x times 1,000x. So I have a negative times a positive. So negative 1,000. I have 14,000x, and I have negative 9,500x. What do you get if you take negative or positive 14,000 and then negative 9,500? 4,500. It's like the cash in my wallet. All right. Then what's the last one? I got 14,000 times 9,500. We're going to go 133,000. What's up? I don't know. We're running low on time right now. It's like number 6 on the priority list. Things keep on jumping up, but maybe tomorrow. All right. What shape? A parabola. Right side up or upside down? Upside down parabola. Shoot, does it have a maximum or a minimum? It has a maximum. I wish I knew how to find the maximum of a parabola. Vertex, negative b divided by 2a. Sweet, we can do this. We own this problem. What is negative b? Negative 4,500 divided by? Sir.
So can we just use the maximum function on our calculator?
You could. To me, it takes longer. I can find the vertex quicker by doing it by hand instead of actually punching my calculator going through that option.
I don't trust myself doing that.
I do trust myself. And I do trust you too, Easton. Here we go. Negative 4,500 divided by 2,000. 2.25. Let's figure out what the heck we just did. Look at my original function. I've got x is the x value. The y value is revenue. Okay? So what does 2.25 represent? Is that x or is that the revenue? That's x. Let's look back to our equation here. Okay? This is the ticket price. 14 minus something is the ticket price. This is the attendance. So what does that mean our ticket price is going to be?
How is 2.25 perfect speed? I'm looking at my calculator and it tells me how much extra.
Yes. And yes, $11.75. This is x. Okay? And I plug it in there. This tells me my ticket price. 14 minus 2.25, 11.75. Yep. Yes.
Yeah, I know we've talked about this before, but I'm always so confused how to figure out which one, X is this and R is this. Wait, yeah, what is R? You know how previous problems are talking about how the Y is equal to the area or the Y?
Yes.
How do you know that?
Right. I hear your question, and I think that the next problem we do will give a really clear illustration of that, and I'll be able to address that better. I don't think that this helps as much, this example. There was a second question, I thought.
What is the revenue?
What do you mean, what is the revenue?
I mean, we could figure that out if we wanted to.
Oh, sure, yeah, exactly. So what you could do is you could take you could take this 2.25 and just plug it in here, and that would give you the revenue.
Oh, okay. But we don't need that.
It doesn't ask for the maximum revenue, right? It just asks for what we should charge. But there is a piece here that I want you guys to understand, and it's just a little bit tricky, but I think you can get it, and it's going to be important to be able to answer one of the questions on your assignment. Please look at this right here. This is the ticket price. This is the attendance. Okay? What would you plug in for X here to get 0? 14. Does everybody see that if you plug in 14 here, that's going to mean that we are charging how much money per ticket? You're charging no money. Does it make sense that you would be getting 0 revenue at that point? Now, suppose we do drop at 14. What's going to happen to our attendance? It's going to go way up, right? Okay, so attendance is going to be really big. Ticket price is going to be 0. We make 0 money. Is everybody okay with that? All right, let's look at the other piece. Suppose, what would X be to make this 0 right here? Negative 9.5. Okay, negative 9.5. Negative 9.5 would make the attendance 0. If you plugged in negative 9.5 right over here, it would be 14 minus negative 9.5. What would the ticket price be? $23.50. So what that tells us is $23.50. If you were to charge that, you'd be getting a lot of money per ticket, but nobody would come anymore because it would be so expensive. See that? You had two things. You had 14. That means if you lower it 14, you get no money, but lots of attendance. And if you have negative 9.5, that means no attendance because the ticket price is going to be way too high. Okay? So it's kind of neat to be able to look at that and understand how it talks to us about the problem. Last example. You guys are doing great. A rectangle is inscribed in a semicircle of radius 16 inches. Oh, wow. Got a gasp there. That's all right. We'll allow that. You don't like circles? I do. I'm not a big fan of... This is the shape that I'm not a big fan of. Like this one right there, I struggle with that one. Like circles are clean. That one, not so much. Yeah, that one, yeah. Okay, rectangles inscribed in a semicircle of radius 16 inches. What dimensions of the rectangle should the rectangle be in order to maximize the area? So I'm going to make a semicircle. I think it's a pretty decent semicircle. I mean, I'm not looking for like, affirmation or praise or anything, but thank you. Appreciate that. Thank you, Ella. Knew I had a fan out there somewhere. And then it says to put a rectangle inside of it.
What's the radius again? The radius is like...
16?
Yeah, but like, what is the radius?
Radius is the distance from the center to the outside of the circle.
Oh, okay. Well, on both sides. If you want to make...
What do I do? Kaylee, what do I do?
No.
Yeah.
No.
Kaylee.
You have to find your equation.
Find my equation. What's my equation?
Area equals length times width.
Awesome. We'll do base times height. Awesome. Love it.
And whatever your radius is.
Yeah. What's my base and my height?
Base.
What? Well, the base would be like that. It would be like 32 to get from one side to the other side of the semicircle. But we're talking about the rectangle, and somebody recognizes that this is a coordinate of x, y. So therefore, I have x units in that direction, and I have x units in that direction, which makes the base 2x. Excellent. Y is the height. The problem is when we multiply, we get areas equal to 2xy. Oh no.
So it's probably axis. How do you get x, comma, y?
So that's a coordinate, right? So xy is just a coordinate.
So we just do it just because?
Yes. If I have a coordinate plane, I can point to any spot on the coordinate plane and say that that's a coordinate, right?
Oh, so that is a general rule of thumb.
Oh yeah. All right. So I can't have two variables. Plug in what?
32. You plug in 16 inches.
Awesome idea. Unfortunately, it doesn't work.
That's the radius. Yeah, I did. Or like whatever. Minor circle. This is 16 minus plugging y.
Okay, so you guys have great ideas. I want you to, if I just flip back to problem 6, understand it says y equals, right? So, what does it say y equals for this one? Yeah, there's nothing there, is there?
What do we do?
Well, what's the shape? It's a circle. Do you know the equation for a circle? Something that you just tested on recently, which is the formula for a circle is x squared plus y squared is equal to r squared. In fact, you're really good at it. A lot of you guys got those problems 100% right on your test. And so if you look, this circle has an equation of x squared plus y squared is equal to, what is the radius? 16. And what do we get if we square 16? Good, 256. So if that's the equation for my circle, could you come up with y equals? Could we solve for y? Yeah, we're going to subtract that x squared to get y squared is equal to 256 minus x squared. How do I solve for y? Square root. And when you square root a variable, in this situation that's squared, know that you have to list both the positive and the negative. So you have 256 minus x squared. Now, let me talk about the positive and negative so you can appreciate that in context of the problem. Okay? True or false? A circle is a function. No, it doesn't pass the vertical line test, does it? So it produces two different functions. The positive is the top part. The negative would be the bottom part. Do you want the top part or do you want the bottom part? We want the top. So therefore, you have y is equal to the root of 256 minus x squared. So yeah, it didn't just say y equals. We had to do something to come up with that. Challenging, yeah, but can we do it? Yeah, we can. Yes. Yeah, let's talk about that. First of all, the minus refers to the lower part of the semicircle, which we're not using. The positive is the top. Now, a common thing that people go through during this time is they take 256 minus x squared. They say, let's take the square root of 256 to get 16. Let's take care of the square root of x squared, which is x. Okay? That we cannot do, and I'll show you why. Okay? If I have the square root of 25 minus 16, what is 25 minus 16? And square root of 9 is 3. But yet, you would go 5 minus 4 is 1. You can't square root over addition and subtraction. Does not work. Does not work. What's that?
I feel like I've definitely been told to do that.
Okay. So I'll try once more. If it doesn't work, then we can visit afterwards. But for example, 2 times x plus 3. Everybody agree that that is simply 2x plus 6? You can multiply over addition and subtraction. But if I told you to take x plus 3 quantity squared, you've told me emphatically that that is not x squared plus 9. Everybody agree? I'm sorry. This is not x squared plus 9. Everybody agree? You can't just use powers over addition and subtraction, which is what you're trying to do in that situation. 256 minus x squared, you're trying to raise that to the 1/2 and take each of those 1/2 power. You cannot do that, just like you can't do that there. Does not work. Let's finish off the problem. Area is equal to 2x times the root of 256 minus x squared. Does anybody know what that shape makes? Does that make a parabola?
No, it makes a little squiggle, right? Square.
Excellent thoughts. Unfortunately, because we have the x in front here and an x squared, we don't really know what it looks like. It's time to kind of just discover what it looks like by looking at our calculator. Yes. Yep. No more problems after today until we get to the final exam. Okay. Now, if I press graph, if I go zoom 6 to get a standard viewing window, Do you notice how I really don't see much of the graph? We have to adjust our window just a little bit. So I want you guys to understand, look at the x value. How big could the x value be?
16.
Could go all the way out to 16, right? So what I'm going to do is I'm going to change my window. I'm going to go x value all the way out to 20. Ella, if we look at our function here, what is this variable? X. What variable goes in place of the y? A.
Wait, why is it A though?
Because A is right where the y would be. Yep, instead of y equals, it's A equals. So, yep, sits right there. Okay? So, what we have here is that the width of the rectangle, we know it could go out to 16, but we don't have any thoughts for the area yet. For example, how do we adjust the height here? Because if I press graph, do you see the top and bottom of this thing? You don't see any of it, do you? I got to figure out how to zoom out. So let's do it. Okay, Laura, I got to make a dimension here. It's got to be somewhere between 0 and 16. How much do you want x to be? All right, great. It's 10. So, everybody okay with x being 10? All right. So, what would the base of the rectangle be? So, 20 would be the base. Everybody okay with that? So, I'm going to figure out what the height would be just so I can get a general idea of how to adjust my window. So, I take 10 and I plug it in here. What's 10 squared? What's 256 minus 100? Anybody approximate what's the square root of 156? 12, 13, around there, right? So let's just choose 13. What's 20 times 13? 260. So we talk about area in the tens, the hundreds, the thousands, hundreds. So let's go ahead and adjust our window so that our area, our y value, is in the hundreds. I'm going to go negative 500, and I'm going to go positive 500. I'll put a tick mark every 100 units. And let's see if we see our graph now. Look at that. I did mess with x. I adjusted x to be negative 20 to positive 20, so I'll get the 16 in there. Okay, we are almost done. How do I find that spot? Second, calculate. Number 4, maximum. I move over to that maximum. And then I move to the left of that spot. Then I move to the right of that spot.
11.31.
11.31 is the x value. And 256 is the area value. Let's try to answer the question. What is the question asking for?
What should the dimension for the rectangle be for the dimension?
So, what is going to be the length of the base if x is 11.31? 22.62 inches is the base because you took the 11.31 and plugged it in for x. Yes? So, how will I come up with this height?
You plug it in for y. Plug in
What do I plug in for y? I plug in the 11.31, right? So I will take the square root of 256 minus 11.31 squared. So I take my y function and I plug in the 11.31 for x and I get, whoa, 11.31. That's interesting. If you think about it, what it just told me is that this x value is 11.31 and the height is 11.31. So that means, that what shape do I have in each quadrant? Yeah, it ends up being that a perfect square is what maximizes the area in those quadrants. Well, thank you. All right, take out your worksheet so I can guide you in some problems.